Welcome to Martin Makes Sense of AI, where I sort through the noise and bring you one important AI story every day. Google has just taken Gemini out of the chat box and put it inside robots that can bend, reach, use tools, recover from mistakes, and even divide work with other robots. That immediately raises the uncomfortable question: if AI can now use a computer and a pair of hands, which jobs are actually safe? By the end of this video, you will know what Gemini Robotics 2 can really do, what Google's polished demonstrations do not prove, and how to use a simple 4-part test to judge whether your own work is exposed before the answer arrives in a company announcement. On July 30th, Google DeepMind introduced Gemini Robotics 2. It is not one robot, and it is not one product you can order for your home. It is better understood as a stack of intelligence that can be connected to different robotic bodies. The first layer, Gemini Robotics 2, turns vision and language into physical actions. Google shows it controlling everything from 2 robotic arms to a full humanoid body, feet, balance, hands, and fingertips. The second layer, Gemini Robotics ER2, is the planner. It can inspect a space, break a longer job into steps, check whether a step worked, and coordinate different robots on a shared task. Then, there is Gemini Robotics on Device 2, designed to run locally when network delay or internet access is a problem. Google says it can adapt to a new robotic body with fewer than 200 examples and a few hours of training. That is the real technical shift. Traditional industrial robots repeat one carefully programmed movement. The new goal is to make the intelligence portable across different bodies, objects, and environments. In the official videos, humanoids pick objects up from the floor, manipulate small items, clean clutter, and work together. The actions are slow, but speed is not the most important part. A slow robot that only knows one movement is a machine tool. One that can understand a new instruction, plan several steps, and work unattended is the beginning of a labor system. That is why people are paying attention. Google Trends shows US YouTube search interest in humanoid robot hitting a 7-day relative peak immediately after the launch. Google's main 3-minute demonstration also collected roughly 200,000 views within its first few days. But this is exactly where we need to slow the story down. A capability demo is not the same thing as a dependable employee. Google published task-level results, and they are much more useful than the most exciting 5 seconds of video. On a humanoid with multi-fingered hands, Google reports a 92% success rate for unscrewing a light bulb. That sounds close to practical. But the same chart reports only 36% for screwing one in, 44% for tying a rubbish bag, 40% for closing a Ziploc bag, and 32% for using a dustpan. For whole-body object pickup, the reported results are also uneven. About 68% from a table, 76% from a shelf, but only 46% from the floor. Those numbers do not make the research unimpressive. They make the story honest. A robot can visibly possess a skill and still fail too often for that skill to be economical or safe. If a person ties a rubbish bag correctly, 99 times out of 100, a robot succeeding 44 times has created a new job called Stand Nearby and Rescue the Robot. And remember the availability. Gemini Robotics 2 is in private preview. The on-device model is with trusted testers. The reasoning model is publicly available for developers, but the physical action systems are not a consumer product rolling through neighborhoods next week. So, no, this announcement does not mean a humanoid is taking your job tomorrow. It does mean the question has changed from, can an AI move in the real world, to how quickly can reliability and cost catch up with the demo? The most useful reaction I found in robotics forums was a demand for longer, continuous demonstrations showing setup, mistakes, retries, and recovery, not only successful 5-second clips. That is a fair standard. If a company shows a robot completing 10 different tasks but removes 9 failed attempts between every success, the video proves range, not reliability. The counter-argument matters too. A machine does not always have to be as fast as a person. If it can work safely overnight, its calendar may matter more than its speed. My view is that both sides are looking at the wrong unit. The unit is not one impressive action, and it is not one complete human job. The useful unit is cost per successful task, including recovery. That forces us to count hardware, training, supervision, maintenance, downtime, and the cost of a bad result. A 70% success rate may be useful for sorting recycling and unacceptable for lifting a patient. If you want AI news explained this way, with the evidence, the limitations, and the practical consequence in the same picture, subscribe to Martin Makes Sense of AI. Now let us turn the robot demo into something you can use. You do not need to predict the year humanoids become cheap. Identify which parts of your work are easiest to automate first. 4 questions, spell R.E.A.L, is repetitive. Moving the same box between marked locations is easier to automate than diagnosing why a machine makes a different noise every Tuesday. Repeated. Measurable actions are easier to train and improve. A is environment. Flat floors, known tools, and labeled shelves help robots. Crowded homes, construction sites, weather, pets, and improvised equipment create edge cases. The first wave is more likely to spread through factories and warehouses than every living room. A is accountability. If one mistake ruins a cardboard box, a company can tolerate experiments. If it injures a person, contaminates food, or destroys equipment, human approval becomes much harder to remove. Google describes its safety approach as layers of semantic, physical, and operational protection. It also says its human proximity stopping work is ongoing research, not a guaranteed safety-rated system. That caveat may be the most important sentence on the entire product page. L is labor economics. Compare the full cost per successful task, including setup, repair, space, idle time, and the human who takes over when confidence drops. Not just a robot's price versus one's salary. A task is most exposed when all 4 answers point in the same direction. It is repetitive, happens in a controlled environment, has a low cost of error, and becomes cheaper after every hidden expense is counted. The useful response is not to become better than a robot at every movement. That is the wrong competition. Build one layer above the movement. First, map your job into tasks. Mark what is repetitive and what depends on judgment, trust, diagnosis, or responsibility. The task map is more honest than the job title. Second, move toward exceptions. Learn why the process fails, how to inspect quality, and how to recover safely. Automation increases the value of people who recognize when the normal process is no longer normal. Third, learn to supervise. Define the objective, set limits, check evidence, and know when to stop. I can use AI is becoming ordinary. I can make an AI-assisted process reliable is a stronger skill. Finally, own a human outcome. Customers do not ultimately care whether a robot moved the parcel. They care that the right parcel arrived, the patient was safe, the repair worked, and someone accepted responsibility when it did not. Google has not announced the end of physical work. It has shown that the same foundation model approach, transforming software, is now reaching robotic bodies with whole body control, longer planning, and early multi-robot coordination. The official failure rates tell us not to confuse a breakthrough with a finished product, but they also show where to watch. When the weakest tasks move from roughly 1 success in 3 to 9 successes in 10, and when the full cost per successful task falls below the human workflow, the labor change will stop being a prediction. My conclusion is simple. Your entire job is probably not next. The most repetitive, controlled, and low-consequence part of it might be. That is what Martin Makes Sense of AI is here to do. Bring you one important AI story every day. Separate the evidence from the noise, and explain what it actually means for you. If you prefer to listen, you can also find the Martin Makes Sense of AI podcast here on YouTube. Subscribe for the next story, and tell me in the comments, which physical task would you happily give to a robot, and which one would you never trust it to do?